Hello everyone, welcome to our channel, and in this video today we will be discussing the problem called next permutation. Its index is 31 and it is the medium problem of the LeetCode. Okay, so let's begin. So in this problem we would be given a permutation of an array of integers, which is an arrangement of its members into a sequence or linear order. For example, if you look out the array that I will be writing over here, is like 1, 2, 3. Now this is actually a permutation sequence where all the elements lies between 1 to n, where n is the length of the array and the frequency of each distinct element is exactly 1. Then it is called a permutation, and the numbers can be in any order. Like you can see, if you find all the permutations of n equal to 3, we'll find something like 1 2 3, 1 3 2, 3 1 2, 2 3 1, and so on. Also, there are total n factorial permutations possible for a given n. Now the next permutation of an array of integers is the next lexicographically greater permutation of its integer. Okay, so we need to find the next lexicographically smallest permutation of a given sequence of integers. Okay, so yeah, we need to find the next permutation of the nums which is given to us, and the replacement must be in place using only constant extra memory. So if you look over the constraints, n is around 100. You can have O of n square solution and O of n cube solution being also passed, but we would be looking for some efficient solution. Okay, so let's understand how we can build up the next lexicographically smallest permutation of the given array. So I'll be first picking up this example 1 2 3. Okay, so this is actually the array that would be given to us. So its length is 3. So if you first write down all the permutations of a 3 length array, you would be writing it as 1 2 3. Then you would be having a 1 3 2. Then you would be having a 2 1 3. Then you would have 2 3 1, and followed by two more permutations which could be 3 1 2 and finally 3 2 1. Now I have written all these permutation in the or lexicographically smallest to largest. You can see this is the very first permutation that is present over here. So what is the next lexicographically smallest permutation that we could have? So this is actually first let me change the color. Okay, so this is this permutation, this is our answer. Next lexicographically smallest after that. Okay, so if you have to answer for this one of the ways is to generate all the permutation and sort it and find the next smallest lexicographically in terms of that permutation. What we would be searching for some efficient solution. Okay, so let's consider one more example. Consider this permutation. Now you can see this is present at the very last. So the next lexicographically smallest does not exist. So in that case we would be returning a sorted array. Okay, so let's understand how we can build up the next lexicographically smallest permutation efficiently. Consider an array something like this. 1 2, let's say 3. Now we would be having 5 and we would be having 4. Okay, so here n is 5 and we need to find the lexicographically smallest next permutation of this given array. Okay, so what we would be doing is like we would be start iterating from the back side of this array. You can see that is from over here. Okay, and whenever we will find some index I such that nums of I is exactly less than, like strictly less than nums of I plus 1, then the element present at the nums of I is going to be replaced with a suitable number, right? Okay, now one thing that you might be wondering that why I am looking for this condition is from the back side of this array. Like I starts from n minus 2 and it goes up to I exactly 0. That is, we would be checking nums of I is strictly less than nums of I plus 1. Then the valid index would be I, and then we are going to do a break statement, and then we will replace the element present at this index with some suitable element that would correspond to some next permutation. Okay, now why I'm doing this, checking this condition. So in the beginning, it might seem tricky to you, but let me explain you in some simpler words. Consider you have a very what we can say decreasing like lexicographically largest permutation. Okay, so you have a lexicographically largest permutation as for a n equal to 5, 5, 4, 3, 2, and 1. Now if you have been asked to find out the next lexicographically smallest permutation of this given permutation, so the best thing that you can do is like you would start iterating from the backside, and whenever you will find a certain element which is not satisfying the criteria of decreasing order, like if you look out from the backside, every element is satisfying the criteria of decreasing order. You can see 4 3 is also satisfying, 3 2 is also satisfying, 2 1 is also satisfying. But consider a certain element where it is not satisfying for a certain index I. Suppose we have a permutation something like this, 4, let's say we have 1 2, then we have 3, sorry, we could be having like 4 5, let's say 1 2. Now whenever you will start iterating from the back side, 5 is satisfying with 4 non-decreasing order condition, and 1 is not being satisfied over here. So what you will do is like you will pick up this one, right, and you need to replace the element present at this position with a suitable position, which is the next lexicographically smallest criteria that must be satisfied. So you should have to replace one. So you will find the element which is just greater than 1 and which is present in the right side. So you will search for the element 4, like 5 and 4 both are greater than 1, but you would be searching for the lexicographically smallest. So you will pick up that element which is just greater than 1, like the next greater element of the element 1 which is present in the right side. Okay, so you will find the element with value 4. Okay, so you will pick up 4 and swap it with 1. So you will be having this one, 4 5 and 1. Now you can see after you have swapped this element, these all the elements are in decreasing order, but you can have the lexicographical smallest element sequence that must be satisfied by reversing this sequence, reversing this sequence. So when you reverse this sequence, you would get 3 2 4 1 5. So this is your answer. So if you are having still some doubts or something like that, so we would be having the elements as 3 2 1 5 4, 3 2 1 5 4. Okay, so you can see 3 2 4 1 5 is the correct sequence. Okay, so let's talk about this example. So the very best case is like you start searching from the very back side, and whenever you find an index I which is not satisfying the decreasing order criteria, then that index element must be replaced. So 5 and 4 is satisfies the condition, and when you are at here, you will see, yeah, it is not satisfying. So you need to replace this 3 with a certain element that is just greater than 3 and which is present in the right side. So we will pick up 4 and reverse like swap it, so it would become 1 2 4 5 3. Now you must have to reverse this sequence of integers because all the elements are previously in decreasing order, and since you need to find the next lexicographically smallest, you need to reverse it. So 1 2 4 3 5 is your correct answer. Okay, so what you are going to do to solve this problem efficiently, let me write the process. So start iterating from the back side. Start iterating I equal to n minus what we are going to say 2 to I exactly equal to 0, and whenever you will find index I, find index j such that uh, nums of j is strictly less than nums of j plus 1. Like first occurrence from n minus 2 to 0, and whenever you will find, you will store it in some variable. Let's call it at index equal to j, and then we will break. Note that j varies from n minus 2 to 0. Let me call it as j over here. Okay, so whenever you will find that, you will do swapping operation, swap of nums of index, and let's call nums of p, where p is the index of the first occurrence of element, which is just greater than nums of index. When you swap that, then you need to reverse the array from index plus 1 to the end of the array. Then you get the next lexicographically smallest. So let's look out how we can implement that efficiently. You can see I have a runtime of 0 ms, faster solution 100%. Okay, so you can see what I've done is like taken n as num size and index as -1. So like it might be possible that you're not going to find any valid index. In that case, this operation will not run, and all we need to do is to reverse the array from index plus 1 to the end of the array. Like find the suitable index nums of I such that nums of it is less than nums of I plus 1, the very first index from the backside. And as soon as you find that index, you will store it and break it out. And when the index is not -1, you need to reverse that index. Like you need to first swap it with a suitable element. So what I will do is start iterating from the backside, and as soon as you will find a element which is just greater than the nums of index, you will swap that, and we are done with that. After swapping, we need to reverse the array from index plus 1 to the last one. So we will use the criteria of two, like you will use the two pointers to solve, to reverse this segment L to R. So this will give you all test cases passed. So if you guys have still any doubts, you can reach out to us through the comment section of the video, and thank you for watching this video.